Hi guys! Okay, so today we have a lesson on multiplying decimals. Oops, too big. And smaller. Okay, let's see. I might have to make it a little smaller, but we'll see. Alright, so our lesson on multiplying decimals. Alright, first things first, make sure you have a fresh, clean page in your notes book. And go ahead and put your header up top. And then let's talk about multiplying decimals. Okay, so last week we were doing adding and subtracting decimals. And we know that the rule for adding and subtracting decimals is make sure the decimals line up. So the decimals in our add-ins have to add up, and then also we have to make sure that our sum has the decimal lined up as well, all right? But in multiplication, it's a little bit different, all right? So let's get to work with that. All right, so let's say a wall in your house is about 5.6 meters by 3.2 meters. And a small can of paint will cover 20 meters squared. And we need to know, is that can of paint enough to paint the wall? So if we're doing the area of the wall, first of all, what I like to do when I have a problem like that, I said a wall in your room. So what shape is your wall usually? A wall in your room is usually a rectangle. The measurements that I gave you should give you a clue as well. I said 5.6 meters by 3.2 meters. So 5.6, if they had been the same, then it would be a square wall. Meters by 3.2 meters. And I like to draw it because it helps give me a visual so that I can keep track of what am I trying to do here? All right. And then I know since I said square meters, I know that's going to be area. Whenever we're talking about square, we're talking about area, okay? So area, you guys all know this. You learned this in like 4th or 5th grade, I think. I think 4th grade, actually. Area is base times height, or length times width. So we know that we have to multiply 5.6 times 3.2. But we're in 6th grade, and we know that the easiest way to do that is to stack them. So when you stack for multiplying, you ignore the decimals. It doesn't matter how many decimal places there are, you ignore the decimals. You just line them up so that the right side is even, okay? So when I stack them, I'm going to try and pretend like there's an imaginary line on the right side, and I'm going to go 5.6 times 3.2, okay? And that helps me keep my problem straight, all right? Okay, so now I actually have to do the math, right? Okay, so 2 times 6 is 12. Carry 1. 2 times 5 is 10, plus 1 is 11. Now notice I'm not putting any decimals. Now I go to my next line. Remember, I use my 0 for my placeholder, and I say 3 times 6 is 18. Carry 1. 3 times 5 is 15, plus 1 is 16. And notice how I'm trying to line my numbers up. Now I add them together. I get 2, 9, 7, 1. Okay, now here's the trick. Now all I have to do is count how many numbers are behind a decimal place. How many numbers are behind the decimal? So in my top number, 5.6, there's one number, one digit behind the decimal. And then in my bottom number, there's one digit behind the decimal. So there's 2. So that means I'm going to count 2 from my imaginary right line. I'm going to count 2. 1, 2. And this was an area problem, so we really should put meters squared. And so now I have to answer the question. The question was, if my can paint 20 square meters, is my can enough to paint the wall? And hopefully you guys all know that the answer is yes. Okay, so another way that we can kind of, I wouldn't say necessarily check our work, but check to make sure that our work makes sense, because that's really important in math. Does my answer make sense? Does the answer I came up with make sense? For instance, if I said there are 4 kids in the class, and each of the 4 kids had 5 cookies, so we have 2 cookies in the class. Does my answer make sense? 4 times 5? Well, my answer is less than the 4 students. So obviously my answer doesn't make sense. And we have to get in the habit of doing that when we're working with math, because a lot of times we make mistakes. It's natural to make mistakes. But if you can look at your answer and ask myself, okay, does my answer make sense for what I was asked? And sometimes you'll catch yourself. You'll catch that you made a silly mistake. So it's a really good question to ask after you solve every problem. Does my answer make sense? All right, so this is kind of a does my answer make sense method, okay? So for this example, we're talking about estimating. Okay, so my problem is going to be 6 times 3.91. Okay, so if I estimate, well, I know I have 6, and I'm multiplying it times, should I say 3 or should I say 4? Well, 3.9 means it's almost 4. So 6 times almost 4 would equal about 24. Okay? So that means after I'm done multiplying, I can go back to this number, 24, and if my answer is close, then I'm probably right, okay? So let's go ahead and try that one. Okay, so once again, remember, I have an imaginary line that I like to, just an imaginary little line, okay? And I've got 3.91 times 6. Notice it doesn't matter that this number is 3 digits long and this number is 1 digit long. They're both lined up to that imaginary line, okay? All right, so, 6 times 1 is 6. 6 times 9 is 54. Carry my 5. 6 times 3 is 18. Plus 5 is 23. Okay, now once again, I'm going to go back to my numbers and I'm going to look for how many digits are behind my decimal. So in my top number, I can see 1, 2 are behind the decimal. But in my bottom number, there is no decimal, but I know, because I'm really smart, that a whole number means the decimal would really be here, wouldn't it? So if the decimal's here, are there any numbers behind the decimal? No. Okay, so just 2 numbers are behind the decimal. So 1, 2, there's my decimal. Okay, now back to the does my answer make sense? So does my answer make sense? 23.46 is almost 24, isn't it? So yes, my answer makes sense. So it's a good estimation. Good job. Okay? Okay, now we have the multiples of powers. Okay, let's say I have 1.35 times 100. Okay, when we're multiplying by powers of 10, I'm going to put it a little smaller. By powers of 10, that's called base 10. You guys should know that. Okay, that's your prior knowledge. You got to activate that. Get it back up into the front of your brain. Because, you know, we left it back there last year. Okay. So when we're multiplying by basically what you're looking at is if you see a 10, 100, 1,000, a 10,000, 100,000, a million, a 500,000, things like that. That's when we can do easy math, okay? So you can move, I'm going to write it in a different color so it stands out. You can move the decimal to the right for each 0. Okay? So essentially, I'm going to rewrite it again over here so that we have it right here. 135 times 100. What I'm saying is I have 1 0, 2 0, right? 2 zeros. Okay. And I'll draw a little line so that you can see that that's not 12. It's pointing at the zeros. So that means I can move my decimal to the right twice. So I can go 1, 2. That's where my new decimal is, which makes my number 135 instead of 1.35. Okay. Whew, lots to do, lots to do. Okay. Okay. So let's look at one more. And this one is a little bit less easy just because there's more numbers, okay? Okay, so we're going to multiply 3.1 times 0.05, okay? And when we do that, we're going to pretend the decimals are not there. And set it up. Okay. Okay, so let's go. Let's go with pretend the decimals aren't there, but we're still writing it. So once again, I pretend I have a line right there. 0.05, and I just line them up. 3.1. Okay, so once again, this is easy. Multiply, just multiply. Ignore those decimals. Okay, 1 times 5 is 5. 1 times 0 is 0. 1 times 0 is 0. Done. I put a 0 to hold my place because I'm in the second spot now, right? I'm in the tens. So 3 times 5 is 15. I carry 1. 3 times 0 is 0. Plus 1 is 1. And 3 times 0 is 0. Okay? Now I add 5 plus 0 is 5. 0 plus 5 is 5. 1 plus 0 is 1. And 0 plus 0 is 0. Don't drop that 0. Leave it there. Okay? All right. And then 4. Now I count my numbers behind the decimal. All right, so now I count my numbers behind the decimal, and again, I'm going up here. This is a decimal right here. I have 1, 2 numbers behind the decimal, and then for my second number, I have 1 digit behind the decimal, so total 3. So that means I'm going to move my decimal 3 times. 1, 2, 3. There is my decimal. So my answer is 0.155. Okay, now you might say, Mrs. Rodriguez, why did you bother writing the 0? Because the 0 is worth nothing. Why can't you just drop it? Well, it's just a proper thing to do in math, that if you have a number that starts with a decimal, you always put a 0 in front of it. I'm not exactly sure why, and I'm going to look that up so I can figure it out and tell you guys, but it's just a proper thing in math that if your number starts with a decimal, there should be a 0 in front of the decimal. Okay? Okay, so I think I have covered everything I want to cover with you guys for today. I am now going to post some practice problems for you to do. And so you're going to look at the practice paper that I post. You're going to copy them into your notebook. You're going to work on them. And then tomorrow we are going to work them out before we move on to our next assignment, okay?